So I have completely forgot. I've completely forgot about answering this, and uh, I really would like to apologize to the person who was asking this question on Matt Scribble's Discord server yesterday because I already fell asleep. So this person posted on the server about this problem, which is the medium derivative, which was available yesterday, but now it's no longer available. It does have a time limit, as it says in that screenshot. It resets in 2 hours, and this was posted yesterday. So of course, the medium derivative is already replaced by a new one. But don't worry, if you want to solve this on your own, you can go ahead and go to dailyintegral.com and then go to archives in the derivatives section. However, you do need coins, game coins, by solving a lot of puzzles within the website so that you can gain some coins in the rewards section. So you do need to grind a lot in this website. So, but anyway, without further ado, it's time. It's about time that I respond to this because another server, another friend of mine, mentioned me to assist this person, but I didn't really help that much because I was doing something else. All right, so this is the problem. Let f of xy is equals to 1 all over 1 minus xy, where the 134th partial derivative with respect to x and y's. I don't know how to read this, but as you can see here, we have 6, 7 on the denominators here. It tells us that, oh wait, this could be a 67. This is a 67th derivative. So, and then when we evaluate that at the coordinate 0, 0 at the origin, so that's gonna give us b factorial squared. So what is that b? The problem asks us to find the value of b. What is that b? Okay, so to start off, we need to check the Maclaurin series of f of x of y. Eh, but first, let's look at this right here. This is incredibly familiar. This is the geometric series. In other words, 1 all over um, 1 minus xy is equals to the infinite sum, the sum from n is equals to 0 to infinity of x raised to the power of n and y raised times y to the raised to the power of n. And this is our geometric series. Now, there is a known Maclaurin series formula for a function of f of x of y, which is a double sum. So in this case, we can also say that this is... Okay, let's first write out what that formula is. So f of x, y, that's going to equals us to the double sum. Alright, so we have the double sum from k is equals to 0 to infinity, and then j factorial k factorial, and then we have this j plus k f all over jx to the j, and then okay, this is our formula. We don't actually have to worry about the infinite series right here. We're not actually going to evaluate the infinite series. What matters here is this entire term right here, this coefficient. So look at this right here. That's very familiar, right? Now look at here, right here, 134. So what is 134? Isn't that 2 times 67? Or 67 times 67 plus 67. 67 plus 67, right? Let's confirm. So what's 67 times 2? 7, 14, 6, 12, 134, 13. So 134. So since this is the same as this, then we can say that J and K is 6, 7, both 6, 7. So that means we will use this. We will use this entire thing too. So this entire term is 1 all over. Okay, let's just go ahead and write that down. So our coefficient is 1 all over 6, 7 factorial times 6, 7 factorial. And then that's multiplied by this partial derivative term right here. Oh, looks like 6. Okay, my bad. So we have that. All right. So we need to match the coefficient from our geometric series expansion. So we need to set this equal to this series right here. And since the coefficient of this geometric series is technically just 1, well, we're going to set it to equal to 1. Boom. And then, watch this. We can go ahead and multiply both sides by 6, 7 times 6, 7. So this cancels out. And then we're going to multiply this by 6, 7 factorial, and then times 6, 7 factorial. And then boom. There we have it. We already figure out the partial derivative. So we did say that when we evaluate this at the origin, it's equals to b factorial squared. But what's this? Isn't that 6, 7 factorial squared? And doesn't that match our given here, our required form here? So that means b is equals to 67. It's that simple. And that is how we solve the problem. We have already solved the problem. Just by using the geometric series and the Maclaurin series for f of x of y, xy, it's trivial. It's easy. We can just go ahead and find the coefficients. Find the coefficients based on this given. Then equate it by the coefficient of this series, which is just 1. And then there we have it. Our answer is b is equal to 67. It's actually that simple.